Dr. Keith Bannister is an astronomer and engineer.
So I basically build telescopes or pieces of telescopes and use them to find out things in the universe that we didn't know before.
Things like fast radio bursts, or FRBs. First discovered in 2007, some of these bursts can release more energy than our sun emits in 80 years, but they last just milliseconds, making them extremely hard to detect.
That's the fun part. We use a telescope in Western Australia called ASCAP. That's a radio telescope and it can see a huge chunk of the sky at once. I liken it to, looking for a needle in a haystack the size of 50 football fields.
But Dr. Bannister has become very good at spotting them. His international team detected 20 FRBs within 18 months of using CSIRO's ASCAP telescope. His more recent modifications to the telescope are now enabling astronomers to detect FRBs in a similar way to watching live-action replays in sport.
So one burst might sort of magically happen one day. This computer will find it, and then it raises its hand and says, "We found something." And when we use that, we can actually go back and zoom in on its exact position.
But while scientists can now pinpoint the home galaxies of FRBs, there's still debate about what actually causes them.
Well, at one point there were more theories about what causes them than there were actual detections of bursts.
Many astronomers suspect they're created by a type of spinning neutron star called a magnetar. But while that debate continues, Dr. Bannister and his team have been using their FRB data to answer another big question. Where is the so-called missing matter of our universe?
There's this magical property that whenever you detect a fast radio burst, it tells you straight away how much gas it's gone through. So you can basically measure the number of atoms between me and the thing that caused the fast radio burst.
For decades, scientists could only account for half of all of the normal matter that should exist. But the FRB signatures allowed Dr. Bannister's colleagues to measure the true density of the universe.
Turns out those baryons, all those atoms, were exactly where we expect, right behind the couch where we thought there was the whole time, right there in the, between galaxies. So that was kind of comforting in the sense that it was where we expected it to be, but it's nice to know that we're actually able to measure it.
Dr. Bannister has been awarded the Pawsey Medal, which recognizes outstanding research in the field of physics.